Welcome to the Team 8 kickoff webinar of the Nairobi Inspire Hackathon 2019. My name is Uta Ween from IHE Delft in the Netherlands. It's my pleasure to welcome you. What should have been a live webinar, unfortunately we've had some technical trouble, so we're recording this, but hey, they say three is a crowd, and I'm lucky to be here with Dr. Jean-Marcel and Dr. Hans van der Kwast from IHE Delft, and the three of us will make this a lively recorded webinar. The Nairobi Inspire Hack 2019 is one of the satellite Inspire Hacks, and is organized in the frame of the IC Africa 2020 conference, and it's a collaborative event amongst a number of organizations, most of all Plan for All and Hackathon. So here you see the wide variety of Inspire Hackathon partners, including some of the projects led by us at IHE Delft. It's all about building a community, building and strengthening relationships between several of the EU projects and members of Africa. So the focus is on building and strengthening those relationships, but also making rapid developments and collecting ideas for future research and innovation. And in particular, this hackathon is focused on addressing societal challenges, such as those in agriculture, environmental sustainability, and with a collaborative open innovation, ICT-enabled entrepreneurship focus. So Team 8 was all about citizen science in Africa to ground truth and exploit Earth observation data. We have a month for this hackathon, so the kickoff is right now, today on the 8th of April. This gives you a glimpse of the team behind the Team 8. You've met myself already. My colleague Kathy Cotton is also helping with the coordination of this hackathon. And we also have three members for the technical background, Simon, Raitis, and Michael, providing support on those who want to really go ahead with developing apps and such things within this team. So today, this kickoff webinar is structured as followed. You have a brief introduction by myself. Then I'll hand over to Hans, who takes us through some concrete examples and experiences of using citizen science for Earth observation. And we have Juan here to discuss with us all kinds of issues related to interoperability, standardization, data quality issues. Just before we get too excited, there's quite a lot that comes into play. And I'd also like to highlight to you the Sizzle call for ideas, which is actually a very concrete opportunity to take the ideas that are being developed in this hackathon forward potentially to funded projects. And of course, we have a discussion. But in the simplest form, we could say that citizens are participating in science. In this context, it means amateurs or non-professionals participating in fields of science that they're not being trained for. On the citizen side, for many people, it's a hobby, it's a fun activity. Some people like doing it because they learn it, but also many people are involved in citizen science because they have very urgent local issues that they would like to table, and they see citizen science as a means to do so. So in Team 8, we want to focus on citizen science in Africa to ground truth and exploit Earth observation data. We can argue that Africa is most in need of innovative solutions to address a whole range of issues, be they related to climate change, water management, land use, population growth, and many others. So in principle, we are excited and see that there's great potential for citizen scientists or the wider public to validate what satellites observe and put those images to use. But in practice, a whole range of different projects, and you see some of those that I lead or have a leading role in at the bottom of the slide. In practice, we see that it's not always that easy. We are faced with a whole range of social, scientific, technical, and also economic challenges when we are trying to implement citizen science. So this Team 8 in the hackathon is all about exploring these challenges and creating innovative solutions using citizen science to ground truth and exploit Earth observation data for specific societal challenges. Back to the challenges for citizen science, here's a quick overview of what those social, scientific, technological, and economic challenges are, and you can see they're quite diverse, and they all require their own means of addressing. So the challenge that Team 8 then wants to look at is how we can link citizen science and Earth observation, both citizen science that we can do in the field, and there's also citizen science that we can do at our desk or, for example, at a mapathon when we're not in the field. And then there's, of course, also another source of input from the citizens via social media. So we can bring these spheres together for a whole range of applications, from natural hazards and crisis management to improving culture, addressing infectious diseases, climate change, and water, and we take account of the challenges that I mentioned before. So we want here in this hackathon generate ideas on those methods, projects, and technical solutions. But in a way, we can also say, let's not start with the solution, let's start with the challenge. And the challenge is really the societal ones that we're facing. Then we see how citizen science and Earth observation have a contribution to make. So this is as far as it goes for my brief introduction in terms of what Team 8 is aiming to do in this hackathon for the next month. And I will now hand over to Hans to inspire us with some concrete examples and experiences of how to use citizen science to ground truth Earth observation.
Hans van der Kwast, and I'm going to show you some examples for innovative citizen science and Earth observation projects. And most of it is based on a very popular citizen science project, which is called OpenStreetMap. So you see here a comparison between OpenStreetMap and Google Maps. And probably you all know Google Maps and use it day to day for navigation. But Google Maps doesn't provide the data for every place on Earth. With Google Maps, you pay with your privacy, and it gives you back an image, picture of a certain area. And the real data is not accessible. There is, however, also OpenStreetMap, which is being mapped by citizens, and that produces data in many places, also the non-urbanized areas, the rural areas. And in this example, we see an area in the Mara in Kenya, where our students during a mapathon have mapped the whole area. While in Google it remains empty. How does that work? First we start with MapSwipe. And with MapSwipe, that's an app on the smartphone where we can see a satellite image. And when we see settlements on the image, we indicate that. And then the tile becomes green. And if we are not sure if it's settlement, because it has a very similar color as background, then we tap twice and it becomes yellow. And if there's a cloud or another error in the image, we do it 3 times and it becomes red. If there's no settlement and no problem, we keep it like it is. And after 6 tiles, we swipe to the next screen. So it's a bit of a Tinder for mapping. And many people do this together and also at least 3 times the same area. So there's some redundancy. And this creates a so-called settlement layer, which is already very, very useful in itself, because there we know roughly where people live on the globe. That settlement layer goes to the HOT task manager. HOT stands for the Humanitarian OpenStreetMap team. And during mapathons, people work on tasks. And because of the MapSwipe tool, it becomes more interesting to do the tasks. Because if MapSwipe wasn't there, we would be looking also at a lot of forested areas and areas where people are not living. And in this way, the tasks are assigned to places where settlements are. So the task manager gives a description of the mapping project and all kinds of instructions and examples, and you can see what other people are mapping at the same time. So that's very useful. And then you organize a mapathon where many people at the same time can map a certain area. So very recently we did a mapathon at IHE for the area that has been affected by the cyclone Idai. And we did that not alone at IHE, also many of our partners and alumni mapped at the same time. So you can do this also online and together. And, in that way, we produced a lot of data which is useful for humanitarian aid. Because the Red Cross, for example, wants to know where people are living that were affected, and they can do estimates of the amount of people that are living in the area. They know the roads to reach the people, and they can use it a lot for also estimating the damage. And it's very easy. Starting from 12 years old, you can do a mapathon. That's not where it stops for us, because that is, of course, very important work to do that for humanitarian aid. But this is real data, not like a picture from Google Maps. So here you see the area around IHE Delft Institute for Water Education. And you see how detailed it is. It contains the traffic lights, the tunnel, the train, the water point in front of our buildings. It's very detailed, and this is real data that you can use in other applications. So there's where hopefully you can get some inspiration of other things you can do with this data. Here you see how you can use the data in GIS. It's open data. And I made a little animation where you can see it for the area that was mapped by our students during the hackathon. So this is QGIS. We look for Older Cassie, searches it in an open database, and we can find the place and puts a dot on the map. When we zoom in, we see in the background the OpenStreetMap. That's a picture, but we know that everything that's on the picture can be downloaded as GIS data that we can use for further analysis. So in this quick example, I'm going to show you how to download the river. Also, as an inspiration for you, QGIS has a lot of third-party plugins, and those are really interesting because you can build your own plugin. And this one is the Quick OSM plugin, which links to the Overpass API. It's a web service, and with a key and a value, you can select certain things. So here I do waterway and river, and I say, give all the waterway rivers in the whole screen. It runs a little script on the server, and it gives back the result. It's not immediately visible because it's overlapping our picture, but now I quickly style it to make the river blue. It's a vector that we downloaded. I switch off the background, and there's the river that we have in our screen. Of course, you see a lot of other blue lines. These are not tagged as river, but as streams. Now, we are not the only ones doing this in the world, so this is an overview for OpenStreetMap mapping communities in Africa. Don't look too much at the difference of the symbols. That's just the way they communicate through WhatsApp or Facebook. But sure, you can find these communities near you. And I was already saying that this should inspire you to develop more tools. And here I just present a few of them. So Maps.me is the alternative through OpenStreetMap to navigate through an area, which uses, in fact, all these things mapped in mapathons or just by citizens in the streets, because you can also map on the streets, track GPS tracks, but there's also another nice tool which is called Street Complete, and that simply asks you all kinds of questions, like what is the name of the street you're now walking, or what's the speed limit here, or what's the pavement of the road. And that's very easy, just using your smartphone while you are walking around. Another nice one is Mapillary. That's the OpenStreetMap variety of Street View from Google. And you see here an example for around IHE Delft. And in the small inset, the green thing with the green dots, these are all kinds of pictures that users have uploaded. And you can just follow a track around the city to find your way. But not based on Google, but on pictures taken by citizens. And there are lots of them. Then in the lower left, you find an example of the Open Route service. And this is a routing algorithm that has been developed by University of Heidelberg. And it goes a bit further than Google Maps, because you can, in this example, get the wheelchair route from IHE building to the old church where we have our graduation ceremonies, for example. But you can also, because it's an open source service, you can also tweak it in such a way that you get the greenest route or the less polluted route. And you see also in the inset that it gives the gradient of your route. So this gives all kinds of nice opportunities. Maybe you want the best route along all kinds of landmarks, or where you find charging equipment for your electric car or your electric bicycle. So lots of things. On the lower right, you see how another tool from University of Heidelberg is used to extract land use data from OpenStreetMap. And it doesn't matter where you zoom in on the globe, you will find the results live in your screen, in your browser, with a pie chart. Of course, it depends on the availability of data, so some places are better mapped than others, but that will still improve through time. So this was my presentation, and I hope this can inspire you to develop nice tools or services based on citizen science and remote sensing. And just remember that the sky is not the limit.
Thank you, Hans. Great. So we've had some inspiration from Hans, so some concrete tools and examples of how we could use citizen science validate Earth observation data, remote sense data. We are focusing on Africa to see where specific societal challenges can actually be tackled by using the combination of these two technologies. So I wonder, which particular challenges should we focus on, or where is the greatest gain to be made? But also technically, what do we need to bear in mind to use citizen science for ground truth? Let's go first.
Well, I can say something that we have talked about open data in your presentation, but I'm not so interested in what is possible to do with open standards. There has been some success on sharing information using open standards, particularly maps, but I'm particularly interested in what is possible to do with sensor data and what public information is there or what we can build with sensor data. Not just because cities are more full of sensors these days, but also because citizen science can use or is using sensors, or the human acts as a sensor in some sense. So I would like to experiment here, if that is a possibility, and there are colleagues that want to do that, with sharing information using sensor standards, and also considering adding semantics to this information in a way that then we can mix it with other information that could be official data or remote sensing data or other streams. Because I believe that the potential of the open data allows us to create from that new visualizations, new applications for using data in ways that we haven't foreseen yet, new visualizations that are possible just because the data is open and the standards that are used to distribute them are open.
I agree with Joanne that standards are really key. Should not be limited to one type of data collection. So to combine in the best way citizen science, remote sensing data and sensors, we need good standards to combine it. Those standards are developed, some exist, some still have to be developed. Citizen science standards are also necessary. They're partly comparable with sensors, but also sensors.
So one of the most common obstacles to the uptake of citizen science is concerns about data quality.
And citizen science, one of the things that give us is redundancy. And from that redundancy, we can extract some uncertainties that can then parameterize and share with the people. So it's not that we say that our data is the best, it's that we share the data with the uncertainties, and then we can compare these uncertainties with other kinds of data and just decide if the uncertainties are in a reasonable amount, but then we have a more dense infrastructure now, more dense coverage, timely or especially, then it might be worth to make use. We have no substitution for that citizen observation.
For people not to share and being afraid of quality is because they think that if you provide data, you are still responsible for how others act. I always give the example with beer bottles. So you're interested to drink a certain beer, but you get a bottle without a label. It's very hard to judge what kind of beer it is. But if it has a label, it says the alcohol percentage, the expiry date, the ingredients, that you should not drive it, drink it, etc. So it's not the bottle that decides the drinking, it's you as a user. So I think to also make people aware of responsibilities of data providers.
So we're starting to talk about users, and of course in citizen science we need to also start talking about people, because at the end of the day, citizens and the public, then help us enrich the picture, if you like. In this particular case, we want to involve them in ground truthing and validating Earth observation data.
Well, one of the immediate things that comes to my mind is that Hans mentioned metadata, and that might scare people. So the important thing here is that we make an application that is attractive, that uses standards, that uses metadata, but nobody knows, because it's hidden behind. The technology needs to make the data usable easily.
You really want to ensure that your citizen science data leads the discussion between citizens and the government.
Great, that shifts the discussion very nicely forward. We've talked about technology, we talked about people, now we're starting to talk about policy, what's this actually for, because otherwise we could be accused of creating solutions looking for a problem. So what are some of the problems? Where is Earth observation data really still in need of that ground truthing, where citizen science can really come in? So, hence you work mostly in water management, where is remote sensing still in need of that ground?
Generally in places that are under-mapped. The only data source you have in many areas where we work at Delft is not having enough ground data or map data. Remote sensing data can of course be used for classifications, and there are all kinds of classifiers available, but without good ground truth data we cannot indication of the quality, that's first, but also to improve the classifiers, to be useful. So I think the most important thing is to have good ground data in some way for remote areas.
Not just about classifiers, it's about models that are creating high-level information from the basic sensors that we have remote. And imagine if the ground truth and the in situ component is so important that the Copernicus service, that is actually the collection of satellites that are out there, and the ground segment that is created have its own in situ component that it's trying to collect as much information as possible. So if we are able to provide them with what they need from the citizen, they will definitely welcome it.
Great. Any final words of wisdom?
Wow, that's really difficult. The only thing that comes to my mind is what once was said, that inspiration and innovation needs to take you working. So please start working and see what happens.
Yeah, my words on that are innovation is connecting the dots. So there's so many modular things around. Innovation is like connecting them in a proper way. Interoperability is important. That should inspire you.
Words of wisdom, and just before we close off the webinar, then we can return to the CISL call for ideas that I mentioned before. Innovation indeed is important, but innovation often isn't easy, and CISL is trying to facilitate that process. Let me switch to the presentation to tell you a bit more about that particular call. So here I would like to tell you more about the call for ideas that's being launched by the Citizen Science Earth Observation Lab that we are running here at IHE Delft. So CISL, so the acronym, you may not immediately sound like what we have pronounced it, but we say CISL. It's an initiative funded by the European Space Agency. And here we are looking for people, organizations who have energy, imagination, and creative talent to help Earth observation data address some of our biggest problems. We mentioned those societal challenges earlier, particularly in Africa. So we are interested in those ideas. We want to help them further and we want to see where citizen scientists and the wider public can really help validate what satellites observe or how we can best put those images to use. As I said before, innovation is important, but often doesn't come off the ground very easily. So this is exactly what we're trying to do with CISL. We're trying to help innovation along in the field of citizen science for Earth observation. We have a whole innovation process here that we've mapped out from an ideation phase to a greenhousing phase to an actual implementation phase. And what's particularly important here is that that first step here of the submission of ideas aligns very nicely with the Nairobi Inspire hackathon, which runs in parallel with this. And so the creation of ideas within the hackathon submitted to the CISL ideas to actually enter the process where best ideas will be shortlisted. Some will be selected for the greenhousing phase, and then a further selection will be made of those projects that will actually be funded and turned into pilot projects. So in the call for ideas, all submitted ideas will be considered for shortlisting by a panel of experts who will evaluate these ideas. And those ideas that are shortlisted will actually be invited to develop full project proposals. We will accompany that process, amongst other things, by a boot camp that will take place at the European Space Agency in Italy in Frascati. And those shortlisted ideas get to pitch their full project proposal to an expert and then they have the chance to receive funding. And very concretely, those ideas that are selected and turned into projects will receive funding between 15,000 and 70,000 euros. But not only the money, we realize in innovation, finance is not the only bottleneck, but training and support of how to really make citizen science work for Earth observation is equally important, and that's what the CISL team is here to provide. There are various inspirations beyond those that we already discussed in this webinar, so please go online, take a look and see what inspires you and which ideas you may want to submit. Here's a summary of the dates I already talked you through. You can also find all this information online, and you can also find the full competition guidelines of what is involved at each of these steps, with a very short and sharp initial submission of ideas and then a more elaborate project proposal. Thank you for this, and thank you also for for listening to our webinar. We look forward to having you participate in the Nairobi Inspire Hackathon. Thank you also to my guests here, Hans and John, for taking part in this. And we look forward to the online interactions as well as the upcoming telcos that we have scheduled. Thank you very much.